Miss Van Ness here. We're going to go over in detail this question. We're going to answer the following questions and we're going to draw a rough sketch of the function. And then I'm also going to do a more detailed sketch of the function just in case you need it. So let's start from the beginning. What's the function's general shape? So first of all, we can get a lot of information just from looking at the leading coefficient. Notice that this function is written in descending order. It is in standard form where the leading coefficient is the highest degree, so that makes it a fourth degree, right? So it's going to have symmetrical end behavior. And a fourth degree with this many coefficients is going to look something like this or something like this. Okay, some sort of W shape. If, by the way, let's put this in a little box over here. If it was just y equals x to the fourth degree, all by itself, there was no other terms, it looks very similar to a parabola, and I encourage you to look this up on Desmos. It looks just a little like sort of a rounded parabola. But because it has all these terms, I know that it's going to have some sort of W shape. Okay, so that's the first question. The next question, does the function face up or down? And again, I can get that information just from the leading coefficient. So the number in front of the x to the fourth is a -1. So the a value is -1. That tells me that it has, let's change our color here, that it looks like this one, right? So it's an upside down W. So that tells me just these two questions tell me the end behavior of our function looks like this. Now, what it does in between there, right, whether it goes like that, or I'm going to do a bunch of different colors here, or it goes like this and it doesn't touch the x-axis, or how high up it goes, all depends, right, maybe it does something like that, all depends on when we factor it and what the x-intercepts are. Okay, so I'll leave those there for a minute because that's a rough idea of what it looks like. And if that's all they ask for and you're choosing, this is a multiple choice question, you're just trying to pick which one it is, you can get a lot of information just when looking at that leading coefficient. All right, let's talk about this next question. What is the function's y-intercept? And again, you can get that when it's in standard form by just looking at the number on the end. Notice there's no x's there. So think about it. When x is 0, we're on the y-axis, that's our y-intercept. Well, if x is 0, all of these terms would become 0, and y would equal -144. Right, so let's just put a dot here. So any of these colored graphs would be a rough shape. The green one, the pink one, the yellow one, those would all count. As long as you put like a dot here and say that right here is the y-intercept. So let's get a little more specific now in case you need it. And let's talk about the last question here is really, it's actually helpful that they tell you this. If one of the factors is x minus 6, how would I show that on the graph? Well, if one of the factors is x minus 6, that means that the x-intercept is 6, 0. Because remember from the zero product property, if that's a factor, that means 6, let's just make it right here, is an x-intercept. And I'm going to prove this to you with synthetic division. So if you're not good at synthetic division, you might want to review a bunch of videos about how to use your synthetic division. We're taking the numbers from our original function, so the -1, the 8, the -96, and the 144, and we're going to put them in a row. We just get to drop down the -1. Above the line, you're multiplying, so 6 times -1 is -6. Below the line, you're adding, so 8 plus -6 is 2. Next, 6 times 2 is 12. 8 plus 12 is 20. 6 times 20 is 120, and -96 plus 120 is 24, and 6 times 24 is 144. Let's extend our line a little bit, and -144 plus 144 is 0. when you get this 0 here in the last line, under the constant term, this is the constant term, then you celebrate. Then you say yay, because when you get a remainder of 0, that means that yes, 6 is dot 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 right here, x-intercept. It also means now that we can take this and turn it into one of the factors. I call it partially factors. So let's do, I think I have it on the next slide. Yes, look right here. So let's go back one thing. Okay, so this is the constant term. This is your x. This is your x squared. And this is your x to the third power. So what this means, let's go to the next slide here, is I have x minus 6 as one of my factors. It told me that. And then we use synthetic division to find this third degree. So this is partially factored. It's not all the way factored. We're going to factor it completely, just in case you need to know it, right? So we did all this information on the previous slide. We have something right now. We know there's a 6 here, x-intercept. We know the y-intercept. We definitely know our end behavior looks like this, so it touches this, and there's something happening over there. We don't know what's happening in between. So we already had a rough sketch. We're going to make it more detailed now. So we're going to take this, and we're going to use synthetic division again, and we're going to see if we can factor it completely. Because what we don't know now is we know there's got to probably be another x-intercept. And we don't know if it goes through this x-intercept of 6 or it bounces. So what do? You use the fundamental theorem of algebra. Remember, there's -1 here. And we use the factors of the constant term over the factors of the leading coefficient. Now, in this case, that's just 24. So we just have to worry about the factors of 24. And it's always plus or minus. So you always start with 1. 2 divides into 24. 3, 4, 6, 8, 12, and 24. I know, that's a lot of factors. That's a lot of possibilities that you could look at and use your synthetic division. Now, you're probably, I can tell you for sure, that you're going to get lucky and only have to do it a couple times. I always start with 1, right? I always go this way down the list. I do 1, and then I do -1, then I do 2, then I do -2. Okay, so this was our original, this one. This is our partially factored, so we have one factor. And now we're going to take this, our cubic function there, and we're going to use synthetic division a couple times to see if we can find another factor. All right, let's do it. So we're using this function right here. So -1, 2, 20, and 24. All right, so you drop down your -1. 1 times -1 is -1. 2 plus -1 is 1. 1 times 1 is 1. This is why I always start with 1. It's super easy. 21 plus 1 is 21. And 1 times 21 is 21. Very exciting. And so 24 plus 21 is 45. So we didn't get a 0 right there. So that's not one of the factors of this cubic function here. All right, let's try -1. So I'm using that same first row, -1, 2, 20, and 24, right? That comes from up here, coefficients in front of our terms and the constant term. Okay, so same process, drop down the -1. Let's make that -1 a little more beautiful. -1 times -1 is 1. 2 plus 1 is 3. -1 times 3 is -3. 20 plus -3 is 17. So it's not going to work either. -1 times 17 is -17. Okay, so nope, that one's not going to work either. All right, let's try 2. -1, 2, 20. You see how you want to get really good at your synthetic division So you can do this as quickly as possible. And if you can do it as quickly as possible, no. Nope, that one didn't work either. Then you can go through your factors as quickly as possible to find them. Now we're doing all of this by hand. I could look it up on Desmos. I could look it up on a graphing calculator. But it's really important you know how to do it by hand in case you need to show all of the steps to do synthetic division. It's important that we know how we get this information. Okay, so -2 times -1 is 2. 2 plus 2 is 4. -2 times 4 is -8. That's 12. Ooh, ooh, ooh. Yes. Very exciting. Okay. So what does that mean? That means that -2, right? So -2, 0 is on the graph, and it means it's one of our x-intercepts. And that totally makes sense based on our end behavior, right? So now we need to figure out, if we just wanted a rough graph, I would say that would be pretty good. Or, yeah, I mean, that would sort of make sense. It can't go back through here, right? Right, that would make sense that it's just touching those unless it has another x-intercept in here and in here, right? But then it would have to go, could do something like that, right? So we're going to figure out if there's more x-intercepts, or is that it? So let's go back to here. So remember from the zero product property that that means that one of the factors is x, right? Because there's a negative in there. X plus 2 is a factor. Okay, so now we have this. Okay, and this right here, let's do it in a different color. This tells us our constant, our x, and our x squared. Okay, so then we have -x squared plus 4x plus 12. I'm just making sure I'm getting all my negatives in the right place. So we used synthetic division and we found another factor that was x plus 2. And now what we have left is this right here. And the reason you should be happy is because this is a quadratic and we have skills to factor a quadratic. We don't have to use synthetic division anymore. We can just do skills for an algebra 1. We can use a diamond, so the AC method, some teachers call it, right? So the A times the C would give me -12x squared and 4x. So you ask yourself, what multiplies to be -12? Or some students like it without the x's, doesn't matter. What multiplies to be -12 and adds together to be 4? Well, 3 and 4 are not going to work. 1 and 12, 2 and 6. So if this is negative, it must be 6 minus 2. So let's do a little box. It's really helpful because this is a negative in front here. So let's do a box. So -2x, 6x. So the only reason to do the diamond was to get these two parts, which then become, can't pick a color here, these two terms, right, which add up to be 4x. And then your C term goes here. So it must be -x here, must be x here, must be +2 here, must be +6 here. So, and 6 times 2 is 12. Yes, okay, so now I have it fully factored. Right, so I took this quadratic and I factored it again. +6. Let's do a little squiggle. Separate our work here. Okay, so that was all our side work. Okay, so that's fully factored. This right here, we can factor out a negative So that gives me x minus 6. Oh, this is not plus 6. Oh, Miss Vanessa, get it together. This is x minus 6. X minus 6. Okay, good. I fixed it. Okay, so this one right here is actually an x minus 6 too. Now notice we have x plus 2 twice, and we have x minus 6 twice. So really what we have is this. Squared x plus 2 squared. That's the fully factored form. I want to write clearly. Okay? So the fully factored form tells us so we have our standard form up here. Okay? And now we have the fully factored form. We can find everything we want to know about this quadratic. So 1, 2, 3, 4, 5, 6. And let's talk about bouncing. And you can scale your x and your y axes any way you go. I'm just going to draw a line here. As long as you label, it's fine. I'm going to put negative 144, and then you have to believe me. Okay, so what this tells me, this from the standard form, I know the end behavior, like we talked about. Okay, so we had this. The original problem told us, I lost some of my work here, told us, oopsies, there. Right? Got it. Told us that it was a fourth degree. They told us that the x plus 6 was one of the factors. We factored it completely, and we got this fully factored form. Because the x minus 6 and the x plus 2, or to the power of 2, those little exponents here, we know it bounces off. Okay, so here's negative 2 right here. Right, negative 2. So that's how I know it touches this point and then goes back down, goes through the y-intercept, touches the x-axis, and goes back down. Ta-da! That's pretty good. That's pretty good for Algebra 2 level. So a little side note, knowing how far exactly, let's do a different color, how far exactly this part swoops, right, and exactly what it looks like, that is a more sort of advanced level. Like it could go, well, don't worry about it. That's beautiful. Here you go. Here's Desmos. This is what I'm talking about. See how it actually swoops down? And there's actually a minimum right here. Try a different color. This minimum point right here. That's something that's like calculus level. So you don't need to worry about that. In Algebra 2, we expect you to be able to find x-intercepts. Those are important. And be able to find a y-intercept. And to know that your end behavior, that it faces down, and it generally is going to have a W shape because it's a fourth degree. This minimum point, again, you don't need to know that. Don't expect you to know that. Okay, that's why I didn't put it on the graph. All right, I hope that was super detailed and helpful enough. I will see you next time. Bye.